Okay, right, welcome everybody. We're going to smash out GCSE Maths Practice Test number 20, non-calc paper. Let's try and move our way through this test, not waste any time. I'm speeding up today. All right, so linear inequalities, deal with these like equations. Just remember to keep the inequality sign the same throughout. The exceptions rule is when you multiply or divide by -1, which I'm going to avoid doing. So I'm going to take away 5 from both sides. 4y, beg your pardon, is greater than 7. Okay, and I'm going to divide both sides by 4, meaning y is greater than 7 over 4. You can write this as a mixed number if you want, although 7/4 or 7/4 is fine. You can write 1 3/4 or 1.75. Although you're not really getting any bonus marks there if you do. It does not matter. Okay, right, let's solve this equation, part B. Let's times both sides by 2. When am I doing that? Well, you'll get rid of the fraction. I love solving fractions, but I like them even more when I like equations better when there is no fractions involved. One less problem to worry about. Anyway, look, use brackets on the left when you do that. Okay, because we're multiplying not just the 6x, but the -5. If I times the right, the fractions just cancel out. So I've just got 4x minus 7. Okay, that's my first line of work, and that'll get you a mark in the exam. Times out your bracket second, so that becomes 12x minus 10 equals 4x minus 7. We'll move all the x's to one side. So I'm going to move the 4x across. So let's subtract 4x from both sides. 8x minus 10 equals -7. Add your 10 to both sides. 8x equals 3. And x equals 3/8. I mean, you can write that 0.375, although does not want you to, doesn't say to rise the decimal. I don't know why you would bother. Okay, that's just one extra step. 3/8 is enough. Okay, any number to the power of 0 is 1, and that goes for algebraic bases. So like x to the power of 0, doesn't matter, will always be 1. Now this, law of indices is the topic you want to review if you don't remember. But usually when the base number is the same, 2 in this case, we add the powers, right? So it's 2 to the power of -3, add 9. That simplifies to +6. And we're told that's equal to 2 to the power of n. Okay, so this equals this. 6 equals n. Done. We're going to do something similar now for the second part. Part C, I suppose that makes it the third. So when you multiply, remember we add this, but when you divide, you subtract. So I'm just focusing on the whole expression on the left. It'll be 206. I'll add the m, but then I'll have to subtract the 214, and that will all be equal to 7 to the -3. Well, if I tidy this power up on the right, I'm going to get, let me think about this, it'll be m minus 8, I believe, and that'll be equal to, yeah, because the positive 206 take away 214, that's going to give me -8, isn't it? Yeah, and that's equal to -3. So m, if I add 8 to both sides, means I get 5. One thing that I'm going to do throughout this paper is just consult with my mark scheme. I don't think I made any mistakes so far, but let me just confirm that. Okay, while I'm getting this warmed up, you can check out question 3 real quick. 1, 6, and 5, it has said, yeah, we're good to go. Number 3, ordinary number, right? Remember, 10 to the power of 4 is a 1 followed by 4 zeros. Okay, with standard form. So yeah, timesing those, 5 times 1 is 5. Add 4 zeros on the end, and your job is done, right? Comma is optional, 50,000. Now, this is slightly hard. I always say with standard form, where would you change the position of this decimal point to make it between 1 and 10? Remember, that's one of the rules of standard form. It's got to be between 1 and 10. I'd put it there, wouldn't you? So to make it 6. Now, you know you're going to multiply by the power of 10. The question is, what are we going to put in the top right corner? Well, for really, really small numbers, we know it's negative, and the decimal point would have needed to have been moved from its original position 1, 2, 3, 4, 5 positions to the right, meaning it's 10 to the -5. Bam, bosh, done. We're speed running. We're not wasting time here. Okay, this table, y equals 6 divided by x. So starting here, y would be 6 divided by 0.5. How many halves go to 6? Well, 12. When you divide by half, you're multiplying by 2, effectively. Next up, we've got 6 divided by 2. That's 3. This one's a bit harder. 6 divided by 4 is 1.5, or 3 halves if you want to write as a decimal. It doesn't really matter which way. 5 is trickier. 6 divided by 5 is going to be 1.2. I'm going to stick to decimals. because it's going to be a lot easier on my graph, right? It's going to ask us now to plot all of these points, right? These pairs are all coordinates you are going to plot on your graph below. Starting with 0.5, which on my x-axis is here, and that goes all the way up to 12. So mark this very carefully. That's your first point, followed by 1, 6 there, 2, 3 there, 3, 2 there, 4 and 1.5 there, 2 more to go, 5 and 1.2. This one can be tricky, be accurate, and lastly 6 and 1. All right, so what you want to do, again, this inequality here and here means we're going to draw the graph from, we're only going to think about coordinates for x from 0.5 to 6. You could draw further apart, you could go all the way up to 0, you can go further than 6, but the question does not really care. It wants to go from your first value to your last. And we join this up, right? Smooth curve. Do not use a ruler. Freehand, please. If the examiner sees a ruler, or any straight lines for that matter, you will lose a method mark. So make sure all your curve is smooth and goes through all those points. Again, I could have done that better. Let me, don't, it's okay to rub stuff out, but it is not okay to use a ruler. So you can do this in phases, there's no problem there. A little wobble's fine, but you've got to make sure that line, or that curve rather, goes through all your points. That's 2 marks. You get 1 mark for all the coordinates plot correctly. Second mark, obviously, a smooth curve. Number 5. All right, another curve. All right, here we're using substitution. Be careful with negatives. Do you know what? Let me do this one last. I'll start with the positive ones just to get our confidence built up, right? So first one, we're just substituting here. X is 4, so 4 squared minus 4 lots of 4 plus 3. I've just changed the letters x, which appears twice to just 4s. So that's 16 minus 16 plus 3. Well, the 16s cancel out. 3 is what you're left with. Same for 2. I'll do the working for that over here. So instead of x squared, I'll write 2 squared minus 4 lots of, 2 plus 3. Again, bid maths, you've got 4 squared minus 8 plus 3. That's going to leave me with negative 1. Okay, I'm going to do the same with the number 1. I'll do it here. So x squared, right, 1 squared. Always good to use brackets. You'll see why in a minute. Take away 4 lots of 1 plus 3. So 1 minus 4 plus 3. That is 0. And now there's one more number to go, right? Let's go with orange. Why not? Now, this is where you've got to be really, really careful, right? I am substituting again, but again, this time I'm going to use, be careful with brackets. So x squared would be minus 2 in brackets squared. Take away 4 lots of brackets minus 2 plus 3, right? So if you've got brackets, minus 2 squared becomes a positive. Minus 4 times minus 2, because we are multiplying 2 negatives here, becomes positive 8. And plus 3 at the end, right? So 4, 8, and 3, add them together, you get 15. Bam. Okay, and kind of like question 4, we're just joining these points together. So let's do blue. Why not? I'm feeling. Why? Yeah, we got to give blue some love, right? So mark your coordinates. Minus 1, 8, all the way up here. Followed by 0, 3 down here. 1, 0. It does dip below the x-axis for 2 and negative 1. 3, 0, and finishing off with 4, 3, which is here. Okay, cool. Like question 4, join the points together. Freehand, no rulers, please. You might have to rub out and sort of have a second take. Some people find rotating the page makes this question easier. You can certainly do that. It's not a problem. But notice how all my points are crossing the x's. If your curve does not cross these points, you're going to be in trouble. Okay, you can extend this line. This part is optional. Okay, but the question only needs to go up to 4. You don't lose marks for that. I thought I'd chuck it in. Why not? Cool. Now, one really useful hint or tip, I suppose. All quadratic graphs have a line of symmetry somewhere. So it's usually where the curve is at its lowest or highest peak or trough. So my line of symmetry is here. It's the line x equals 2. I know this question doesn't ask for this. This is a little bonus detail. Ask yourself, does your line look symmetrical about that line? If it doesn't, if one side looks sort of higher than the other, double check your numbers and your work. And you don't get, some questions can and often ask, what is the line of symmetry? So do be prepared for a question like that. Didn't appear this year on this particular paper, but I have seen in the past, so be warned. All right, next up, number 6. We've, again, a lot of similar topics are repeating themselves here. Very unlikely in a real thing, but we'll do it anyway. Add the powers, right? X to the 9. Here, be really, really careful. The trap is, well, we times all the powers inside the brackets by 3. There is one sort of hidden power here on the number 4, 4 to the power of 1. Remember, the squared only belongs to the letter y. 4 is raised to the first power. Why am I bothering doing that here? Well, because you're timesing not just the 2, but the 1 at the beginning by 3. So actually the correct working is 4 cubed, y to the power of 6. I've times both numbers in the brackets by 3. That should get you both marks. Again, if you want to be double sure, do work out 4 cubed, which is 4 times 4 times 4, 64y, 6. That is the better of the two answers. That should get you full marks, but the word simplify, I'm not sure if they would allow 4 cubes. So write 64 to be safe. Cool. Right, factorising quadratics. Remember, we want two numbers. When the number in front of n squared is 1, life's a lot easier. We can use team, right? Team stands for times for the end, add for the middle. So times for the end number, which is a positive 12, and add for the middle, which is negative 7. Always think about the sign in front of n, not just the number. So I'm thinking about two numbers that multiply to give a positive number, but add to give negative. I know both numbers are going to be negative here because a negative times a negative times to give positive 12, and that's the only way I'll be able to get a minus 7. I think the two numbers are minus 3 and minus 4. Okay, yeah, because if you times these two numbers, you do get a positive 12, and if you add them, you get a negative 7. So factorize, put in double brackets. It's n at the front of each one, and then minus 3, minus 4 in next to the ends. You can write n minus 4 first, followed by minus 3. It is not a big deal. Number 7, expand and simplify. This is number 6 in reverse. Ignore the little n at the beginning. We're just going to focus on expanding n minus 4 bracket 3n plus 5 first. So we'll do FOIL. FOIL stands for, well, F stands for the first 2. So I'm multiplying n by 3n. That's 3n squared. Then FOIL, the second letter is O, standing for the outer 2 terms. So n multiplied by 5, that's a positive 5n. I in FOIL stands for inner 2 terms, so negative 4 multiplied by 3n, that's negative 12n. And L stands for the last 2 terms. Minus 4 times positive 5, that's negative 20. I'm going to simplify this, or the middle 2 terms, because you'll notice they are like terms. So that's minus 7n minus 20. Now, we are almost done. Remember, all I've done is I multiplied these two brackets. I still need to deal with the n at the front. Okay, but what we can do now is we can replace those double brackets with just one single bracket. That's 3n squared minus 7n minus 20. And the last step really is just to times each of those 3 terms by the n at the front. So this bit should be quite easy. 3n cubed, you increase the power by 1, minus 7n squared. And then we're multiplying n by negative 20, so minus 20n. Okay, so 3n cubed minus 7n squared minus 20. There are other ways, but again, I think this is the easiest, most efficient method. If you did it in an alternative approach, feel free to give yourself a tick. Okay, number 8, n is an integer. So what integer values can satisfy this inequality? Remember, this means greater than or equal to negative 2. That means minus 2 is allowed. And we're just going to go up in whole numbers. So it could be minus 2, it could be minus 1, it can even be 0, it could be 1, it can be 2, but it cannot be 3. This sign means strictly less than 3, okay? 3 is not cool. You are not allowed to use that. That would be sacrilege, some would say. All right, so we want to represent this inequality, right? So, no, we don't. We want to represent this new one. Y is less than or equal to positive 1. So put a little circle above 1. Equals, you're allowed to choose 1 itself, so shade that circle in. And we want numbers less than 1, right? Numbers less than 1 go this way. So don't forget to draw a little y above that, but y is any number on that line I've just drawn. Very good. Number 9. Okay, right. We all know straight line equations all follow the general format of y equals mx plus c. Okay, this is true for all straight line graphs. M is the gradient and c is the y-intercept. Now, we know this. The gradient is minus 3. So we know that it will definitely be y equals minus 3x plus c. And lo and behold, look, it even tells you where it crosses the y-axis. So where it crosses the y-axis, by definition, is the y-intercept. So c will be 5, right? So the equation is y equals minus 3x plus 5. The less popular correct answer, you could say 5 take away 3x, although, you've just swapped the 5 and minus 3x around. You can do that, but very rarely do I see that. So I'm imagining most smart schemes are going to go with the first one. Okay, we've got 6 identical squares. And the total area is 5406. Estimate the length of one side. Okay. All right. So we've got 6. The first thing I'm going to do is I'm going to divide by 6. 5406. Usually it says estimate. Now I could round it to 5,000. Usually you round each number to 1SF when we estimate, but I don't think dividing by 6 here is that much more difficult than dividing by 5,000. 5,000 divided by 6, I'm still going to use bus stop method. So I don't think there's any gains to be had by rounding 5406 to 1SF. I'm just going to do it this way. So 6 doesn't go into 5, carry the 5 across. 5 goes into 54 9 times. 5 does not go into 6, and 5. All right, so yeah, it goes in 901 times. Okay. So each area, or the area of each square, is 901 centimeters squared. Okay. This is a bit where estimating is going to be useful, all right? Because with a non-calc, you're not going to square 901. That's not possible. But 900 is actually not as hard as it looks. So let's round it now to 1 SF, because we can square root 900 easily, okay? If you split this up into surds, remember, we can split square roots up into the square root of 9 times the square root of 100. Square root of 9 being 3, square root of 100 being 10. So we can say that each square has a approximate length of 30 cm. Okay, approximately 30 centimeters. I'm going to look at the mark scheme and see how they dealt with it. I would not be surprised if they did it identically. Number 10. Yeah, they've got 30 or so. So well done if you said that. Okay, right. Question 11. We are doing graphical inequalities. If you know more about this topic, that is the one. Okay, so this one, x is x is smaller than or equal to 6. Right, the way you want to treat this is just imagine they're all equals signs. You want to draw the line of this graph, right? So x equals 6 is the vertical line over 6. Because anywhere on this line, no matter where you put your finger on that blue line, the x-coordinate will always be 6. We're going to do the same now for this one. Y is greater than 2. So it's and anywhere on this line where you stop, the x-coordinate will change on that sort of purple line, but the y-coordinate will always be 2. Now for the third one, y equals x plus 1. I like the table of values method. Again, if you know what it is already off by heart, because you've done a million of these, don't worry. Okay, but I just choose any 3 random coordinates for x, and you can substitute. So when x is 1, y is 1 plus 1, 2. When x is 2, y is 3. And when x is 3, y is 4. And you can plot these 3 pairs of coordinates, and you'll get a good idea of what the graph looks like once you've done that, because it is a straight line. So we go 1, 2 for the first pair, 2, 3 for the second, and 3, 4. It's a straight diagonal line, isn't it, going through like this. So with a ruler, draw your 3 straight lines. Now, don't always take the biggest mistake here is people always think it's the triangle, and it kind of often is, but it isn't always. So how can we with certainty know that it is the triangle they want, and not say, because I've seen years where this was the correct answer and people always default to, it must be the triangle. Here's how you need to think about it, right? X is less than 6. Well, that is to the left of this blue line, right? If anywhere left of this blue line, the x-coordinate is going to be a number that's less than 6. Likewise, for the line y is greater than 2, it'll be any point above this line. The part people struggle with the most is kind of the orange line. Which side do I do? Because it is confusing. And I always say this, right? Pick any point on your graph, Okay, let's say 0, 0, for example. Substitute these into your inequality. And if the inequality makes sense, you have chosen the right side. So, for example, if you chose 0, 0, you would say, well, y is 0. Is that less than or equal to 0 plus 1? Is 0 less than 1? Yes. So it is this side. And just to sort of paint a picture, what do I mean by it makes sense? Well, look, if I picked a different coordinate, forget what the work I just did there, but imagine I picked, any random number will work, but like let's say this coordinate here, which is x would be 0, y would be 8. If you subbed it in here, you would get 8 is less than or equal to 0 plus 1. Is 8 a number less than or equal to 1? No, it isn't. Doesn't make sense. So it is not that side. I hope that helps, year 11. So it's sort of this side of the orange, it's this side of the sort of purple line, and it's this side of the blue line. There is only one region where all three of those lines are going to be happy. And yeah, it is the sort of default safe answer. It is the triangle. So I have had years where it is one of the other regions. Okay, but more often than not, it is that. So if you're really, really lost and you're baffed, commit to one of the areas. But yeah, you got to be able to sort of justify to yourself. Now, one final point I thought I'd mention. Usually, one of the three inequalities could be like this. So not y is less than or equal to x plus 1, but it might say something along the lines of y is strictly less than x plus 1. The only difference you would do here is rather than a solid line, okay, you would draw a dotted line instead. So be ready for that. So I know that's not this particular question, okay, but it's worth me mentioning because I have seen that in the past. But when you add the extra line, you do add the extra line there. Cool, moving on. Okay, make tea the subject. Oh, I do love a good tea. Indeed, chai tea is always a good shout. All right, let's make tea the subject. Make tea the subject means we want to end with t equals something, right? Right now it's n squared equals something. That's no good. Right. Here's what you do. You multiply across your t cubed, so n squared t cubed equals 4dt plus t cubed. Now, we're going to move everything with t to one side, everything without to the other. So I'm going to move the t cubed across. So this becomes nt cubed minus t cubed equals 4d. And then I'm going to factorize out the t cubed. All right. So we're going to factorize here, meaning if you noticed, both terms on the left have a t cubed. We'll write a bracket n squared minus 1. And that equals 4d. Okay, divide both sides by n squared minus 1. So t cubed equals 4d over n squared minus 1. And obviously we want to do the opposite of cubing. So we need a cube root both sides. So the cube root of t cubed is t. You will need to do a cube root sign here. 4d over n squared minus 1. Let me just consult with my mark scheme. I'm pretty confident, but, mistakes can happen. That's interesting. So my computer doesn't want to open the document for some reason. Give me 5 seconds. I'm going to reopen it. Hopefully it works now because I do want to confirm question 12. While I wait and confirm this, get a little sneaky peek of 13. And question 12, let me drag it down, is I can confirm happily that 4d, the cube root of 4d over n squared minus 1 is correct. You can include, the mark scheme does have brackets here, but they are totally optional. So if you left yours in, don't panic, you do get marks. But let's press on. Right, number 13. Right, cumulative frequency graphs. The median mark, right? There are 60 students. Median means the middle student, right? Half of 60 is 30. So we want to know what the 30th student, if we all lined them up, would have got. So do your line going across with a ruler. Again, on an iPad, that's kind of hard. I'm getting 48 is my median mark. Again, they do let you, they give you a square of grace either side. So if you said 46 to 50, you would be forgiven. Now, who gained 58 marks or less? So 58 being here. No, it's not. Beg your pardon. 58 is here. I can't believe I almost read 58 from the y-axis. I bet a lot of people made that mistake. It's the marks we're looking at. And going across, I get 46. So 46 is part B. Again, give yourself sort of one either side of that grace. So 45, 47 is fine. Intervals of rain, right. So remember quartiles here. Quartiles, like the name suggests, breaks your data into quarters. We've got 60 people. If I work out a quarter of that, we would get 15, right? 60 divided by 4, 15. These are our quartiles will happen in intervals of 15. So the 15th person, which I've just drawn in purple, is the lower quartile. Okay, it's 40. Now the next sort of quartile, we don't really call it a quartile. In fact, some people do call it Q1. And then people use Q2. Now, this is more commonly known as the median. Because, I mean, 2/4 is a half, and the halfway point on a list is the median. Kind of makes sense. Now, the upper quartile, or Q3, we just go up in 15s, don't we? So it'll be the 45th person, which going across, if I'm very, very careful, do use a ruler here. Don't leave things to chance. I'm only doing that because it's an iPad. I'm getting 56. So 56. So we've got the interquartile range, just like normal range. You take the biggest away from the smallest, but instead of sort of the max and minimum, we're doing upper quartile minus lower quartile. So that's 56 minus 40, which is 16, is your IQR. Now, looking at the mark scheme, Dave said 16 to 18. So, and that's because like you can be a box out on either of those. Okay, so we've got the IQR of geometry is 9. This one was algebra. So the IQR tells you how spread out your scores are, right? It tells you the middle 50% of students have a gap of 16, right? So meaning like the person that was sort of the top 25% and bottom 25%, they're 60 marks apart. With geometry, that's the gap's only 19. So geometry test people are more consistent. Students' marks are more spread out than a geometry test. Yes. IQR tells us how spread out our test scores are. Now, mark scheme says the following. It says B1, so you get follow through mark. Yes, the IQ on algebra is greater than the geometry test. So since geometry lower, they like it when you say lower or higher for either one. It's more consistent. Cool. To be awarded a grade A in algebra, a student had to gain a mark of greater than 64. 2 students are going to be chosen at random. Use a graph to find an estimate that both of these, right. You might be thinking this is easy to begin with, but there's a lot of hidden traps here we've got to be careful of, right? So first of all, look at 64 marks. How many students are scoring more than 64? So 64 is there. Let me use the orange now. 64, 64. Go up, go up, go up, go up, go up, go up, go up. So 50 students are scoring less than that. So there's a gap. 10 students are doing better, right? So there's 10 students scoring better than 64. So the probability that one student I choose, there is a 10 in 60 chance. So student 1 there is a 10 in 60 chance. But the second, if I pick 2 in a row, the reason this is difficult is, well, you kind of already chosen one person. You're not allowed to choose the same guy or girl twice. There'll be 59 to choose from for your second choice. And obviously, it would have gone down by 1 as well, right? There'll only be 9 students having done that well. So we need to multiply both of these fractions. To make your life easier, though, we want to simplify the first one, right? So 10/60ths is 1/6 times 9 over 59. You can cross cancel here. So if you divide the top and bottom diagonally by 3, you get 2 on the bottom there, 3 on the top there. So to wrap things up, the probability would be 1 times 3 is 3 over 2 times 59, which is 118. I don't think that simplifies. Let's see the mark scheme. It does say exactly that, 3 over 118. Tough question. I mean, you may have got different numbers because of the accuracy of you reading off your community frequency graph. I'm not going to detail those alternative answers. Do ask me if you got something you think is close and merit worthy. I will look at that. Next up, we've got adding fractions. So the common denominator of these three, well, we've got 2 and 4. Let's focus on just the numbers first. We want all of our denominators to have the number 4 in. But obviously the first 2 fractions have denominator x. We're going to need x in all 3 of our fractions as well. Okay, that'll be the common denominator here. So that means we only multiply the first one by 4, top and bottom. So the first fraction will be 12 over 4x. The second one, I am going to multiply top and bottom. Well, 2x has just been multiplied by 2. So remember to multiply both terms on top. So it'll be 2x plus 4. And lastly, the last one's only been multiplied top and bottom by x. So it'll be just x. Cool. So let's now add these. So what I'm doing, they all can share the 4x now, but I'm doing 12 plus 2x plus 4 plus x. Add these together. So 12 and 4 is 16. 2 and 1 is 3x. All over 4x. Right, job done. I think that's correct. Let me consult with my mark scheme. It is most certainly that. Again, if you're getting numbers, maybe you chose a slightly bigger common denominator, you would be expected to cancel that down. Again, you may have written a 3x first and then the 16. It really does not matter. Okay. Next question, number 15. Right. All circle theorems. We love a good circle theorem. Let's not waste time. ADB. So I want ADB, this angle here. What is it? That's the objective of this question. Give each. Okay. So, what can we say about this triangle? Okay. So, or this circle, should I say? Right. Focus on the blue to begin with. Yeah. Bear with. So the first thing I'm going to do is, this is a semicircle, right? It tells you it's a diameter, so it's a semicircle, right? So we're going to start by saying angle ABC equals 90 degrees. And my reason is angles subtended by a semicircle, and you can replace the word semicircle with diameter, are 90 degrees. Cool. Next up, next reason, I'm going to find this angle right here. Now, don't feel like you're only allowed to use reasons from the unit circle theorems. We can use any legit method, right? As long as it's geometrical. You can use angle facts from all the way from back in year 7 if it is valid. So I'm then going to do angle BCA. Now, this is angles in a triangle. So to work out BCA, I just do 180, take away that 90 there, and then I need to take away the 55, because this is angles in a triangle, right? So doing all of that, well, 180, take away 90 is 90, take away 55, I'm left with 35. Cool. So that's 35, and the reason, and yes, you have to say each one if you want the communication mark at the end. Angles in a triangle add up to 180 degrees. Okay, again, yeah, look, that's a year 7 angle fact. You can use that. Cool. Now, I'm going to rub it out. I'm going to rub some lines out. For example, I'm not going to need that anymore because I just want you to focus on this last step. You should know, right, that if I draw 2 lines from this arc, let's say for argument's sake that is 20 degrees. If you draw 2 straight lines from the same arc, from there and there, look, notice how both those straight lines are coming from the same arc. You can also say that's 20 degrees, right? A lot of people nickname this the bow tie theorem. You won't get marks for that in a GCSE by saying bow tie angles are the same. No, okay. But I'm going to show you exactly what you can say right now. Now, that idea, you can rotate your page, but look, it's the same principle. Here we've got an arc, or a chord, or a segment. Any 3 words work. But you've got 2 straight lines coming off that to create this 35-degree angle we spoke about earlier. And we're doing exactly the same thing here and here, aren't we? So you're drawing 2 straight lines off the same arc. So we can wrap this up by saying angle BDA equals 35 degrees. And my reasoning is angles subtended by the same, and you have a sort of, you can use any of the following 3 words I'm about to use. You could have said segment, because segment is like the whole shaded area like that, because technically those 2 straight lines are on the same segment. You could have said chord, because yes, those 2 lines are kind of coming off this chord. And, you know, they're giving you every single chance. You could have also said arc, because both those straight lines are coming off this arc. So insert your preferred word here, but angles subtended by the same segment chord arc are equal. You must say the equals part. This is very important. Okay, but yeah, that's the right answer. ADB. I know I wrote BDA, but it's just the letters in reverse. Okay, ADB. Yeah, it's probably better that I write. Yeah, write in correct order. I don't want to leave anything to chance. Yeah, but I'm pretty convinced, even if you're at angle BDA, that you have the marks. That would be harsh because it is technically the same angle. Okay. All right, moving on. Number 16. Given that these are integers, whole numbers, we're going to do this. Right, this is called completing the square, if you want to know more. Now, the way this works, completing the square, is we're going to ignore the 19, right? That comes later. I like to look at the first 2 terms. So we're going to look at 3x squared plus 12. We're going to factorize this like linearly, right? We're not going to do team. I'm just going to do the old-fashioned factorize 3 bracket x squared plus 4x. Okay. Now, the trick is you always halve this number. Always. Always halve it, because that will be that's going to be the letter B. So half of 4 is 2. It'll be x plus 2 squared. Yeah? Why is that, you ask? Well, because if you expand this as a double bracket, you can do team here to work this out. You would get x squared plus 4x plus 4 at the end. Now, the good news is we wanted that. That was good. I wanted the x squared, and I also wanted the 4x too. What I did not want, and what is an unwanted extra, is the plus 4. So what we need to do to sort of fix this extra 4 is we'll take it away, right? Because if I take it away, these 2 things cancel out, and I've got exactly that. So what I'll do, I'll write this underneath. It's going to be 3 bracket. I'm going to use square brackets here because I've just rewritten all of that as x plus 2 squared. But remember, I take away the 4. And then I can close the brackets. Cool. This is the bit where we can chuck the 19 back. So look, remember, this was plus 19. I haven't forgotten about 19, but I think now is a good time to bring it back. We're almost done here. So what I want you to do is we're going to take everything in the squared bracket and we're going to multiply it by 3. So we'll do 3 lots of x plus 2 in bracket squared. So that becomes 3 bracket x plus 2 squared. Leave that bit alone. 3 lots of negative 4, that's minus 12, plus 19. Okay, tidy up the 12, negative 12 and 19. So your answer is 3 bracket x plus 2 squared plus 7. Now, I'm going to do a weird way of checking my answer, right? In an exam, you can't obviously, I can look at the mark scheme and I would say, by the way, this is the final answer before I explain how I'm going to check my answer. Okay, so we're happy with this, or at least I hope so. You can always check your answer by expanding again, right? If you expand it properly, so x plus 2 squared is x squared plus 4x plus 4, close brackets, plus 7, times everything by 3. So you get 3x squared plus 12x plus 12 plus 7. 12 and 7 is 19. You'll notice that this is exactly what the question said at the very, very beginning. And that's a great sign. If you're not, you can check your answer by expanding whatever you think this is. And it should be what the original question was asking you to do. So, do you know what? I'm not even going to check my answer. I'm 99% sure that's right. Number 17, Venn diagrams. Right. We've got A union B. So A union B is everything inside A and B or both, right? So all 3 sections. Now, there is a bit of a difference. You have to be ready for both questions. If it said, what is the set A union B? You would have to say, well, the numbers in A union B are the numbers 6, 3, 8, and 2. 6, 3, 8, and 2. Now, it wants the numbers of elements. Right, so confusingly, what it's actually saying, what the 6 means, what the 3 means, what the 2 means, is they've actually counted the number of elements, right? And this could be anything. It could be, you say, right, we've got A, B, C, D, E, and F. Like, imagine there's 6 letters there. What they've said is they've sort of simplified it for you, and they said, well, look, there's just 6 elements. You could have G, H, and I. And you get the idea, right? So they've done that bit. They've they've counted how many elements in each set there would usually be. So n, the function, if you see an n before it, it's basically saying how many numbers are in both of these circles. So basically we're just adding 6, 3, 8, and 2 all together, which adds up to 19. Nice. So that's A and B. I'm going to rub it out for each question because that makes my life easier. A union C, again, we're just looking at circles U and C now, so same thing, just slightly different. Although, sorry, I was about to do B and C, wasn't I? I am looking at A and C. Right, so A is this circle here. Just because they're not joined together doesn't change anything. Obviously, there's just no overlap to double count. So actually, this is a little bit easier. 6, 3, 2, and 5 are the numbers I'm adding here. So 6 plus 3, 9, plus 7, is 16. Very good. I've just added both numbers in, or all 4 numbers in both circles. 7 plus 9, 16. And, okay, this is where it gets a bit trickier. So B, obviously, is this circle. Now, intersect means and. So in your head, think, I need it to be B and C apostrophe means not C. So which region is both B but also not C? Well, it's this region here, isn't it? Because these 2 regions are B, but they're also not C. So be 8 and 3, that's 11. Last one, we got a bit of a tough one here. Actually, C and D are both tough. A and B are slightly easier here, but this means not A. Not A. So not A union not B. So not A is this region here. Not B would be anything outside B. And not C would be this region here. Now, usually with union, we just say count anything that's shaded in. But the funny thing here is, with union, you don't have to think about where they overlap. Union means just anything that's been shaded, count that. And you'll notice we shaded the whole Venn diagram in. So we're just going to add all the numbers together. That's the question we're being asked. So to wrap things up, 6, 3, 8, 2, and 5. If we add these together, well, 8 and 2 is 10. Plus 5 and 6, 11. That's 21. 24. Right. Easy money. I'll confirm this with the mark scheme. I'm pretty confident so far. So what was that, number 17? We've got... A is 19. Interestingly, part 2 says 0. I'm going to explore this in a minute. Part C is 11 and part 4 is 28. Now, I'm a bit baffled. I am... The number of elements that are B... Yeah, I think I'm going to overrule the mark scheme on this. Sometimes what the mark scheme does... wait, no, I will concede. I will concede here. So, the last question I did make a mistake because I forgot to count this area here, didn't I? So, yes, the last one is 28. Apologies there, people. I will concede that I made a mistake there. Number 3, B and not C. It is saying in the mark scheme... Actually, no, it is agreeing there with that one, 11. Part 2, it's saying is 0. The number of A union C is 16. The mark scheme is saying 0, and I suspect I know why. I suspect the mark scheme is saying 0 because I suspect the mark scheme wanted probably to ask you this. This is where do both A and C overlap? There is no overlap, meaning it's 0, isn't it? So I suspect maybe this is from a shadow paper, I don't know, but yeah. Interesting, but I am going to stand by my 16. Mark scheme says 0, but I think that's why, because they were probably meant to say intercept C, but that's not what I see on my paper. Number 18, we've got a curve. F of x has one turning point, and it gives you the coordinates of that. It's -6, -4. Wait a minute. Hang on a minute. All right, so f of x plus 5, this is transformations of graphs. If you add 5, it usually increases all coordinates by, it translates by the vector 0, 5, right? Meaning it shifts your graph up. So it means the x will stay the same, but all y coordinates will increase by 5 units. So I'm going to add 5 on purpose to just the y coordinate. It'll be -6, 1. I've just added 5 onto -4. Now this shrinks your curve. So y equals f3x. If I had a graph like this, f of 3x basically squishes it by scale factor whatever number is in front of x inside the bracket, in this case 3. It basically means all your x coordinates get divided by 3. So that means I would divide the x coordinate here by 3. So divide your x coordinate -6 by 3, you get -2, -4. The y coordinate remains unchanged. Just consult my mark scheme here. It agrees with both A and B for my working here, or part 1, part 2. So let's press on. Okay, now we got a graph, y equals gx. Now 2gx means we stretch vertically. It's a stretch about the x-axis scale factor 2. So basically multiply all y coordinates by 2. You don't have to do all of them, just do the ones that matter, right? So for example, there, the y coordinate's -1, double that. So the x coordinates remains the same, but that y coordinate will double to -2, right? 2 lots of -1 is -2. This 2 lots of 4 will be 8. Again, this kind of goes off your graph, so maybe not the best point to have chosen. Again, that y coordinate will double to become 2. This coordinate will double to become 2 lots of 2, 4. X coordinates, points on the x axis remain unchanged. But yeah, look, your graph, all your y coordinates get doubled. Okay, so this is what your graph will look like. Be careful. But yeah, that's y equals 2gx. Cool. Right, last part. The graph y equals h. Okay, so it intersects the x-axis at 2 points. Okay, right, hang on. I'm going to rub this line out. It's just going to help me visualize the last part of this question. It might be tricky. I do not know. But I know that it might be getting in the way. So let's have a look. The graph y equals hx, which is a new function, intersects the x-axis at 2 points. Minus 1, 0, and 6, 0. Minus 1, 0. So here, and 6, 0 over here. Okay. The graph of h of x plus a passes through the coordinates 2, 0, where a is a constant. Okay. Now, I mean, look, I don't know what the rest of the graph looks like. Let's just imagine it could be a quadratic. It doesn't really matter. Okay, but you could draw any graph. You know, imagine that's your h of x, right? Y equals hx. All right. What it's saying is we're gonna move it, and one of the new points will be 2, 2, 0, right? So there's two ways that you could make this happen. Okay. So you could either move the original graph 2 units to the right, or 3 units to the right, sorry, and it will look like that, right? So 3 units to the right. Fair enough. Alternatively, you could move it 4 units to the left and end up sort of with this curve instead. So there's two things that could have happened. Hence why it's asking for two possible solutions for A. Well, let's look at the first one, which is this. Imagine the original graph has moved 3 units to the right. Well, that's usually, when we move to the right, you actually take away 3. So it will be y equals h of x minus 3. That would mean move your original graph 3 units to the right. Now the other one would be move your units move the graph 4 units to the left. So this would be plus 4. So this could be either hx minus 3 or hx plus 4. So the two possible values of a are negative 3 and positive 4. Okay, well done if you got that. Okay, interesting stuff now. This is law of indices. So cube root, remember, there's a lot going on here. So we've got 1 over x. Now think of cube root as the power of 1/3. And then remember, because it's raised to the 4th power, I'll use square brackets here. Now, a few tricks you can employ. 1 over x, so we're going to rewrite this not as a fraction, but we're going to write it as x to the minus 1. And in square brackets, I'm going to write to the 1/3, and outside I'm going to write 4. So, I mean, it doesn't matter which order you do this in, but we can, I'm going to go from the inside out. So let's focus on just this bit here. We can say everything in that square bracket is x to the minus 1/3. I've just multiplied by minus 1 by 1/3. So it's x to the minus 1/3. I've just multiplied them together. And then you multiply these two to get x to the minus 4/3. Okay, so all of that is 4/3. And we're told that that is equal to x to the m. Well, we've got, they're both the same power, isn't it? M is minus 4/3. Okay, we are done. Let me confirm this with the mark scheme. I don't think that's too much of a challenge. Number 20, we're getting towards the end now. Okay, rightio. Where are we? 3 consecutive whole numbers. Sum of the square of the smallest number and the square of the largest number is always 2 more than twice this. All right, there's a lot of vocab going here. Let's break it down. consecutive numbers. Right, so you'll get a mark for identifying that. You can use the letter N or X. I like N. If you did this using X, don't panic. But any three consecutive numbers are N, N plus 1, and N plus 2. You can do sort of N minus 1, N, and N plus 1. You know what? There's so many ways you can start this question. I'm gonna do it this way. I think most people go with this method. But yeah, I'm just saying, look, if you wrote N minus 1, N, and then N plus 1. Again, technically these are three consecutive numbers. You are going to get the same proof. You will prove correctly, but obviously your working might look slightly different to mine. Right, what does it say? The sum of the square of the smallest and the square of the largest number. So let's do that, right? Smallest number, N squared. Square this, you get, it's a bit trickier, but it's going to be N plus 2 in brackets squared, which if you use FOIL, you're going to get N squared plus 4N plus 4. So remember what this question is saying. It's saying if you add these two together, is always 2 more than twice the square of the middle number. Okay, well, let's square that. If I square that, I'm going to get N squared plus 2N plus 1. Okay, so let's break it down, because there's a lot of wording here. I think people fail this not because they don't get it. It's just because the wording is very confusing. Okay, so let's break it down. The sum of the square of the smallest number and the square of the larger number. Let's just add those together. That plus that, right? If I add those together, I am going to get something that is 2n squared plus 4n plus 4 is always 2 more than twice the square of the middle number. Well, we need to double this. So twice, we've got the square of the middle number. What's twice that? Well, it will be 2n squared plus 4n plus 2. Well, look, let's compare. Is this 2 more than that? Yeah. So a nice way of breaking it down is this is 2n squared plus 4n plus 2. Put that in brackets, plus 2. So it's, yes, it is always 2 more. Okay, super hard. Because yeah, if you compare it to this, it is 2 more, isn't it? Right, you got the 2n squared, you got your 4n, but obviously 4 is bigger than 2 by 2 units. So yeah, we've done that. Cool. Right, surely we're getting close to the end now, right? Speed run is almost complete. Right, we've got all right, estimate the gradient. I love estimate gradients. Where x is 2. So identify where x equals 2 is. It's right there. We need to draw a tangent. So a straight line that crosses that point at one point only. There's my tangent. Now, you can draw your line as long as you want, but the important part is it touches your curve only once. Now, pick any 2 endpoints on this line. I'm going to pick there and there because they're nice numbers to read. And you've got rise over run for gradient, haven't you, right? So it rises to, the run is, was that 1.5 and 2.5 is 1. So the gradient is rise over run, 2 divided by 1. Just be careful of your how the graph is scaled, because originally the x and y axis are not scaled equally. If you said the gradient was 1, you fell for their trap. The gradient is in fact 2. Yeah. Very good. 3 marks. That's very generous. Okay, so we've reached the end. We're now on question number 22. And it's a diagram with lots of vectors. And the M is the midpoint. N is on a point that O, N, and Y make a straight line. And given that O, N to O, Y is lambda to 1, use a vector method to find the value of lambda. So basically, if you want to visualize what this question exactly is asking you to do, this basically is, well, we'll do ON, which is lambda. This length here is going to be lambda, and OY we'll say is 1 part. So basically you need to say what fraction of the length is ON out of OY. Okay, and in order to do that, you're going to have to find, what they are in terms of A and B. So let's start easy. Let's just start today by saying, well, what is OY? Okay, O to Y. Well, you go along this way, right? You'd go up this way and across that way. So OX is, let me write this down just because this will be worth marks to the examiner. So I'm literally just working out, and by the way, if this is all you can do, at least you'll get 1 mark, right? So definitely write it. You may not understand the rest of the question. This is by far the hardest GCSE higher has to offer. So I don't blame you for struggling here, but I would blame you if you're not at least trying to get marks here. So OY is OX plus XY, which we know is literally A plus B. Okay, and this will be useful later. Okay, well, I'm going to write sort of these things. OY over here, A plus B. Fair enough. Okay, so I'm going to kind of break down stuff I know, and there is going to be a lot of working here. This is the hardest, one of the hardest of the hard of all GCSE questions, so there'll be a lot of writing. Please, if you get lost, rewind, kind of come back. Okay, so here's my next move. I want to actually work out what O to N actually is. Now, the O to N bit, this bit here is fine. This is just a half, because OX is A, so from O to X, this line is A. So OM would be A over 2. Okay, fair enough. But what I really need and what I really like is MN, which I don't know. Okay? But let me write down N first. So I am going to use this blue to just write that. Okay? In fact, let me go back to MN. Because I don't know how many A's and B's each one's going to have, let me just say this will have X lots of A. So it'll be a combination of some of these plus some lots of Y. Right? Because everything here can be written in terms of X and Y. So it'll be, X and B. So I'll say Y lots of B. Right? And X and Y are numbers I'm going to work out. Right? They're just placeholders for now. But it'll be that purple line, just think of it as some amount of A plus some amount of B would give me the vector M to N. Cool. So, why am I writing this? Well, I can write ON as this bit first, so that A over 2, plus this purple line I wrote earlier, right? Plus that. XA plus Y lots of B. Now, I'm going to tidy this up a little bit. I've noticed that I can factorize out the A. So let's do that. My tablet's playing up. So I'm going to write A in brackets, because that's common to both the first two terms, a half plus X plus Y lots of B. Okay. Just to be even sort of more neater, usually, I'll write A on this side. Not that it matters, but I want you to just see something. Now, we said that line OY is A plus B, right? This line here is A plus B. This one right here. And it's not letting me draw, of course, because it's been difficult. There we go. OY is A plus B. We know this. Now, ON, the sort of blue line I just worked out with all the X's and Y's, that is parallel. Now, there's something really important we can say about the blue and the orange line, right? If they're parallel, that means that we should be able to write ON as a scalar of OY, right? Now, if you look at OY, you've got the same coefficient in front of both A and B. I mean, not that they've written it here, but you can imagine OY is 1A plus 1B. This is a really important finding. For lines to be parallel, they have to have the same proportion or ratio of A's as they would have B's. Why is this important, you ask? Because that means that these numbers for A and B have to be identical. And in order to preserve the straight length, this has to be identical to this. So one of our first main findings is that 1/2 plus x equals y. Okay, and I'll come back to that later, right? That's an important finding. So whatever number you want to put in front of x, you would have to have a half on and have that in front of y. Fair enough. Now let's do something similar. So let me rub that out. I will come back to this working in a moment. But the next part I want to work out is I want to go, let me rub all that out. I'm going to look at this other line from M to Z, right? Because I'm told that this line here is 3B, right? OZ is 3B, it's in the question. So, I'm not even going to show the working here. I'm just going to write M to Z. Actually, I'm going to show working because it's a good exam technique. It's going to be MO plus OZ. MO, you're going against the arrow for this MO, so it'll be minus A over 2 plus OZ 3B. Okay, and we can kind of do something similar again. Now, I know I said earlier that no, sorry, forget what I just said there. I am going to work out, I know that MNZ is a straight line as well. So MZ is a straight line. So I want an expression for just MN, that bit there. Yeah? So let me get an expression for that. I've already used, again, I want to understand this relationship a little bit better. So I know I said, I know I said earlier it was XA plus YB. And in fact, there is no problem with me saying that once. Yeah, let's say XA plus YB. Because it is the same exact line as before. And because it's in a straight line, let's see. Let's see what's going on here with this MZ. So MZ, if you think about it this way, if I sort of think about the ratio of A to the ratio of B, think of this as minus 1/2 A plus 3B. This number is exactly not just 6 times the first number, but it's also been negated. So the second number, the amount of, in this particular case, Y has to be negative 6 times whatever A is, which is interesting. So it has to be 2 things. So let's try and write an equation. So let's sort of try and make sense of this. What I'm trying to say here is, because it's a straight line, it won't be exactly minus half and 3B, but it has to be whatever number you're choosing for your A coefficient. To get your B coefficient, you'd have to multiply by negative 6. So what we're going to say is whatever x, remember we generalized and said, right, let's say that number's x lots of A. B would have to be minus 6 lots of this. So wouldn't it be minus 6 x B? Meaning this bit here, y, is equal to negative 6 lots of x. Now, look at this. We've got 2 unknowns. 2 equations and 2 unknowns. We can solve the simultaneous equation, okay? So what I'm going to do here is I'm just going to replace x with negative 6. So half plus x equals, not y this time, but negative 6x. So solving this, various ways you can do it. I'm going to move the negative 6 to the left, because then it becomes positive. So let's do it that way. So you've got 7x equals minus 1/2. If we times both sides by, divide both sides by 7, you get x is minus 1/14. Okay, so major finding. And just to prove to myself, right, does this number work? Does it work on both lines, right? So if we're saying that the number in front of a would be negative 1/14, this would be minus 1/14. And this would be, 6/14 b. Fair enough, that kind of works. And this one here, again, if I had a half to negative 1, so if I do a half plus, this is me just checking my answer, minus 1/14. Again, if I want to, this would be what, 14? 7/14. So in this case, y would be 3/7. So I'd end up with, I'm happy with this. So let's wrap this up. Let's wrap it up, right? What we're saying is x is minus 1/14, meaning y is half. Well, we add a half on, don't we? So minus 1/14 plus a half, which because we need to add these together. Let's make it 7/14. Okay, that's just my half. So minus 14 over plus 7/14. That gives me y is 6/14, which you can or cannot simplify. So let's generalize, right? So what we're saying here is the purple line, the one that is so important, is, remember, I wanted to work out ON, didn't I? So ON, I'll switch back to blue just to keep the nice color-coded syncing up. So ON is, remember, a/2 plus x lots of a, which we said was negative 1/14 a, because that was our value of x, plus y lots of b, which we worked out was 6/14 b. Now, if we tidy up these two, we did a similar sum earlier, didn't we, where we did a half plus, we did that already. We know it's 6/14 as well. So it'll be 6/14 a plus 6/14 b. Okay. Now remember, it wants to have lambda, doesn't it? So it wants the fraction of the amount. Well, the fraction is 6/14, isn't it? So that means that we can lay out this length here is 6/14 of a plus b. So we can sort of factorize the 6/14 out. A plus b So if we think about the ratio of ON to OY, you've got 6/14 for ON. You've got, 1 for OY, because that's the question. Let's simplify, right? We hate fractions with ratio. This bit's the easy part. Times both by 14 to remove the denominator. So you'll get 6 to 14. We can halve both sides to simplify, right? So you get on the left 3 and on the right 7. So the answer, the ratio will be 3 to 7. However, that's the simplified version. They are insisting on our ratio. I hate to trip up on the finish line here, but they're insisting for this question that it has to be written in the form sort of n to 1, where the second number is deliberately 1. So it does mean we will have a fraction in our answer. So, you know what, 3 to 7 is really good, but to sort of not leave anything to chance, we want the second number to be 1 deliberately, so divide the second number by 7. If you divide the right by 7, divide the left by 7. So you get 3/7, don't you? So that's your value of lambda, right? I'll write the working underneath. So ON to NY, to OY, sorry. If we want to write it in lambda to 1, will be 3/7 to 1. So lambda is 3/7. And that's got to be top 10 hardest GCSE questions I've seen. Ratio is already hard in itself. This incredibly challenging. There are other ways you could have got to this answer. Okay. If you found a sort of easier way or more interesting way, do let me know, and I'm happy to share that knowledge, right? I'm always wanting to learn new methods. So thanks for tuning in, and I'll see you on the next video. Okay, so it just occurred to me that it'd be really handy if I just showed you the answers at the end, in case I did make any mistakes in the working. So feel free, I'm going to be scrolling down, feel free to fast forward and pause the section you would like to see the answers to. If you prefer this rather than watching the video, mark the ones that you are confident with here. You can do that quickly, save yourself a lot of time, and rewind the video to the bits you really want to know more about. So here are the answers. I'll do this quietly, but yeah, let's go. And interestingly, just to get an idea of what grade you're working at, they've given a mark scheme here. Personally, I think the sort of most useful line to look at is the very, very bottom, meaning, the one in yellow. And again, they do use decimals here. So the reason behind that is obviously on a sort of they've just, this was not a real exam paper. So they've kind of sort of used decimalization here. Just know that if I use, for example, grade 9 as an example, I haven't got my writing tool, I'm afraid. If you look at the bottom line, for grade 9, you'd expect to get 67.53. So you could say like a 68 out of 80, because that's sort of the first whole number over 67.5 will get you grade 9, 55 marks for a grade 8, 44 for a grade 7. Just round those numbers up. The reason they're decimals is because obviously they're taking averages, and this is what they would expect on a national scale. So, the easy way and the safe way to look at it is just round up to the nearest mark. That's what you need for that grade.